Let's continue our discussion on acid-base properties of salt solutions by looking at salts that come from weak acids and weak bases. So if we have sodium acetate, we can look at the sodium plus and the acetate minus ions in solution. We can say that the Na plus is going to be our conjugate acid of NaOH. And we showed from the previous video that this has no effect on the pH. If we look at the acetate ion, this is going to be the conjugate base of HC2H3O2, okay, or acetic acid, which is a weak acid. So therefore, this is going to influence our pH. So it's going to influence it based on two ways. So we have a salt, it's a strong electrolyte, completely dissociates in solution. So now we just have Na plus ions and C2H3O2 minus ions. So we need to figure out what the pH of this resulting solution is going to be. So if we take water and we place Na plus ions in that solution, just like we saw in the last video, we're going to get no reaction. Okay, so we don't have any species that are either H plus or OH minus, so it's not going to contribute to the pH. On the other hand, if we take water and place acetate ions in that solution, we're going to have an equilibrium with HC2H3O2 plus OH minus. Here, our OH minus ions are going to make the solution basic, and our pH is going to be greater than 7. Okay, so a particular solution here, or this particular salt solution, is going to be basic. Now let's look at something that might contain, in this case right here, we can look at this salt that comes from the conjugate of a strong base and of a weak acid. The same situation is going to happen if we had a strong acid and a weak base. But what if we have a salt solution like this, where we have NH4 C2H3O2, and that salt is going to be in equilibrium with NH4 plus C2H3O2 minus. So here we have the conjugate acid of a weak base, and here we have the conjugate base of a weak acid. So it's not as easy and straightforward as it was in this first case, because we only had one species to look at. So in this instance, we must compare the Ka and the Kb. If the Ka is greater than the Kb, then the pH is going to be less than 7, and our solution is going to be acidic. If, on the other hand, the Kb is greater than the Ka, the pH is going to be greater than the 7, and our solution is going to be basic. So in each of these instances, if we have either the cation or the anion that comes from a strong acid or a strong base, and one that comes from a weak acid or base, we only need to look at one of the cations, just like we did in this first case, and determine the pH. But in our second example right here, if we have the conjugate acid of a weak base and the conjugate base of a weak acid, in order to figure out if it's going to be acidic or basic, we have to look into the Ka. If the Ka is greater than the Kb, the pH is going to be less than 7 and the solution is going to be acidic. But if the Kb is greater than the Ka, the pH is going to be greater than 7 and our solution is going to be basic. So this is how you would use some general rules of thumb to determine whether or not a salt solution will be acidic, basic, or neutral.